Now we're moving on to work with quadratic equations that are in the standard form. Now I want you to consistently, on a problem like this, not a word problem, but on a regular problem where you're graphing and finding the vertex and the intercepts, I want you to begin by rewriting in vertex form first. That process requires completing the square. Now some of you may prefer to sub in y in place of n of x first, just to make it easier to manipulate. And let me remind you that we complete the square for the x squared minus 6x part. So let me move the negative 5 out of the way first, so I can focus on just the x's on the right hand side. And remember, when we complete the square, we add to both sides of the equation. Now, remember, completing the square involves you saying half of 6, which is 3. Since it's minus 6x, it's minus 3 in the parentheses. And remember, if I squared this binomial, I'd get x squared minus 6x plus 9. So you take half of 6, get this 3. 3 squared is 9. What I add to one side, I add to the other. So clean up the left-hand side and make it y plus 4. Then all you have to do is isolate y. So y equals x minus 3 squared minus 4. And you can see that I not only isolated y, I went ahead and renamed it n of x. Well, let's do p of x the same way. So I'm going to say y minus 19 equals 1 half x squared plus 6x. I need to complete the square for the x part, but the problem is I can't complete the square if I lead with anything other than 1 half. So let me show you two ways you can do this. Number one, I can multiply everything by 2 and get 2y minus 38 equals 2 times 1 half, or 1x squared. 2 times 6x is 12x. So this is one way some of you may prefer to do this. And you will have x plus half of 12 is 6. 6 squared is 36. But that gives you 2y minus 2 equals x plus 6 squared. 2y equals x plus 6 squared plus 2. Well, now it's time to isolate y. So 1y, which is the same as p of x, is equal to x plus 6 squared divided by 2, written more correctly as 1 half x plus 6 squared, and then 2 divided by 2. Now, some of you may prefer the other method for completing the square, which is really what I prefer to do. In this case, you're going to say y minus 19 plus, and instead of multiplying everything by 2, I'm going to factor the 1 half. Guys, when you factor out a fraction, the middle term tends to get larger. So remember, what you've got is 1 half x squared, half of 12x is your 6x you started with, and then I'm going to have to say the 1 half comes down. I still complete the square for the x squared plus 12x part. I'm still going to get x plus 6 squared. 6 squared is still 36, but notice when you do half of the 36, it's 18. So this gives you y minus 1, and then you don't have to divide through at the end. You've already got everything set up. So both of those are going to lead to the same outcome. And I'm all right with whichever one you choose. Just make sure you become very good at the one you choose. See, now we can go to our sketch because we've got it in vertex form. So now these problems are like the previous problem. So I can see on this one, I'm going to say right 3, down 4. The a value is 1, so out 1, up 1 on both sides. Now on this particular problem, I know the vertex already. That's the beauty of vertex form. So I'm going to say the vertex form is 3, negative 4. I can also on this one see that it will have x-intercepts, so I do in fact need to do the work. So I can take the original x squared minus 6x plus 5 standard form, set it equal to 0, or I can take the vertex form and set it equal to 0. One might seem easier to you than another. I'll go ahead and tell you though, if you've done the work for vertex form, it makes the x-intercepts, in my opinion, easier as well. So plus or minus the square root of 4 is 2. 3 plus or minus 2 is going to give you 3 plus 2 and 3 minus 2. And if you look, if the roots are supposed to be at 1 and 5, then I can tell that even though my first sketch was a little off, I can still see that what's going on is correct. Hey, by the way, if you work with the vertex or the standard form, and you simply factor, so it would have to be minus 5 minus 1 multiplies out to positive 5 and adds up to negative 6, you're going to get the same result for the x-intercepts. So two different ways to find the x-intercepts. Y-intercept is always easy, usually from standard forms the easiest, because if you plug in from the standard form, you plug in 0 for x, you'll have 0 minus 0 plus 5. This is plugging in the standard form. So that's telling you your y-intercept is at 0, 5. But plugging the 0 into the vertex form is also easy. You would have y equals 0 minus 3 squared minus 4. Well, 0 minus 3 is negative 3 squared is 9 minus 4. That also gives you 5. So when you've got both standard form and vertex form, you have more options. But I would say, if it were me, I would use standard form for the y-intercept in general, if I have both, and I would use vertex form for the x-intercept if I have both. All right, well, let's do the same work on p of x. So I'm going to sketch it first, because when you sketch it, you can definitely use your sketch to inform your algebra work, and that's the point. So I can see that I'm going to go left 6 from the x plus 6 part, and then up 1 from the plus 1 part. And I can go out 1, up a half, because my a value is 1/2. That's not good, though. I could go out 2, and instead of going up 4, I could go up 2. I think I like that option better. So from the vertex, out 2, up 2 in both directions. So out 2, up 2. Oh, I tell you what, I'm liking this problem because the rest of my work is going to be really easy. Again, I can see the vertex is at negative 6, 1. I've already used that. I like this problem because the x-intercepts are often the most cumbersome or time-consuming thing to do. And I can see from this parabola, which opens up and hovers above the x-axis, there is no x-intercept. I like that. I'm going to use the standard form to get my y-intercept. So when I plug it in, I get y equals 0 plus 0 plus 19, plugging into the standard form. So I'm going to get 0, 19. Now notice, I'm not drawing this parabola all the way up to 0, 19, but I can see that if it extended until the point that it crossed the x or the y-axis, it would be really high. So 0, 19 makes sense. All right, let's do one more of these problems. So on q of x, again, I'm going to start by rewriting in vertex form. So remember, we complete the square for the x's, so I want that 3 on my y side. I want to get it out of the way. I also know that I cannot complete the square with the negative 3 leading, so I simply factor it out. So be careful with your signs. It would have to be negative 3x squared. Negative 3 times positive 2 is negative 6x. Now on the right side, the negative 3 drops down. I've got to create a perfect square binomial. It's going to be x plus, since it's plus 2x, it's plus here. Half of this 2 is 1. 1 squared is 1. And remember, when you continue your distribution, negative 3 times 1 is negative 3. Oh, I like that. The left side really reduces down. I could name this q of x or y, by the way. So I'm ready to sketch. I can see that this parabola is going to move left 1, and that's it. It doesn't move up or down. The a value is -3, so I'm going to go out 1, down 3 on both sides. Hey, I like that because going out 1, down 3 just gave me the y-intercept. So this one's going to be super fast because everything I need is already visible. The vertex is at -1, 0. On x-intercepts, since the vertex is on the x-axis, or since the parabola is hanging from the x-axis, I can see automatically that -1's a double root. And last but not least, when I sketched it, I got the point where it crossed the y-axis, so no work. I'm just going to look at my graph and use it to my benefit. All right, ready for more practice?